Today we're talking about a comparison mat, which is a mat of tiles next to another mat of tiles, and we're trying to see which one is greater. So a little bit of a review with the algebra tiles. If you remember, the shaded is positive and the unshaded is negative. So we look at this collection of tiles, what is the value? And we can see that this is 4 positives and 2 negatives. So 4 positives and 2 negatives will give you a value of 2. Now this points out what a zero pair is, because working with zero pairs earlier, we realized that we can take zero pairs and just sort of take them out of the expression, which gives us those two that we saw from the beginning. So a zero pair is a pair of opposites that add to 0. Okay, in this case it would be 1 and negative 1, or you can say that this is 2 and negative 2. Okay, so either way it does the same thing. So the importance of the zero pair, it breaks down the value to its simplest form. And that's our goal, is just to break things down into the simplest form possible so that we can solve problems a little bit more easily. So if we look at this first expression mat, you have mat A and mat B. This is called an expression mat, comparison mat. And we're trying to find out which one is greater. So first thing we need to do is just sort of look at the values of the different types of tiles. Mat A, you have 5 positives and 3 negatives, so that would give you 5 plus negative 3. Mat B, 2 positives and 5 negatives, would give you 2 plus negative 5. And now what we're going to do is what's called a legal move. This is our first legal move. We're going to just remove zeros from the left and the right. Okay, so first of all, we look at this mat A, and you have 2 positives and 2 negatives, right? And a positive 2 plus negative 2 is equal to 0. Any other opposites, we have here a positive 1 and a negative 1, and those are 0. So if you remember from a previous lesson, this is how we show zero pairs. Zero pairs are circled and crossed out. So that's very important. Now, this allows us to now see we have 2 positives left over, right? We took out a zero pair. So that leaves us with 2 on the left. And then on the right, let's take out those 0 pairs. We have positive 2 and negative 2. And that leaves us with 3 negatives. So now if we look at the overall values of these, we can see that mat A is bigger than mat B because 2 is bigger than negative 3. So we say mat A is greater than. This is a symbol for greater than, right? And it's important to point out how much greater is A than B. Okay, so if mat A is 2 and mat B is 3, this is greater by 5. And this is a very key point, because anything that we're going to do or we have done to this comparison mat, it should always be greater by 5. Okay, so I'm going to highlight that. Very important key. It's greater than mat B by 5. This basically says how these two mats are related. How they're related to each other. One's bigger than the other by this many. So what we just saw was called a legal move, because what a legal move does is whenever you have two values that you're comparing, it should not affect the value of the relationship. Okay, so to put it in simplest terms, the relationship between the two mats is not changed. What that means is, before we even started and we had 5 plus negative 3 and 2 plus negative 5, mat A was already bigger than mat B by 5. And what we did is we just weeded out what we didn't really need to see that relationship, and we can see that it's bigger by 5 by looking at the 2 and the negative 3, right? It's in simplest form. So let's look at the how this works. Now, when we're removing 0 pairs from a mat, all it does is it just takes away 0. And what happens when we take 0 away from any number? So take 0 away. When we take 0 away from a number, it doesn't affect it at all. Okay, this does not affect a value. Does not affect the value. Okay, now the other type of legal move that we're going to see today is called removing matching sets. So what happens is we know that one mat might be bigger than the other. So if we remove something from one side, that's going to change the relationship between the two values. But if we remove the same thing from the other side, it restores that balance, whatever that relationship is. Okay, for example, whatever this is, I'm going to remove that unknown number. Okay, now this one is going to have a different relationship with that one by whatever number that is, until we do the exact same thing to the other side. Okay, so we'll do practice with this, but basically what this does is it removes equal or identical amounts from both sides. And this does not affect the relationship. Okay, so this legal move that doesn't affect the value, which also does not affect the relationship, and removing equal amounts from both sides keeps that balance, whatever it is, the same. Okay, it's like what we did over here. We had 2 and negative 3. After we took away 0, the relationship was the same. Okay, so let's look at this first example. On the comparison mat, find a way to determine which one is bigger. So first thing we're going to do is we're going to state, well, what is the original value? Okay, and we're just going to call that the OG value. And the original value, if you look at what's on mat A, you have x squared plus negative x. And then plus negative 5. Okay, that's what we have on the mat A. Now on mat B, we have x squared plus negative x plus negative 4. Okay, and typically I'll just put minus 4 and minus x, but just to point out the fact that we're always adding, these are always collections of tiles, which are sums, technically. Okay, so here is our original. So I'm going to put the steps on the left, and then we're going to do our legal moves and see what we end up with. Okay, so the first thing I could do is I'm going to do my first legal move, which is removing 0 pairs. So this is a 0 pair, and this is a 0 pair. I have a number and its opposite, a number and its opposite. Even though we don't know what it is, they're identical tiles of opposite colors, of opposite shades. So my first step was I removed zeros. Okay, and what did I end up with? I now have x squared plus negative 5. So already we can see that this expression has gotten simpler. And then here I have x squared plus negative 4. Okay, it might still be not clear to some of us which one is greater than the other. So let's just see if we can break it down any more. Okay, so we can see I have no more 0 pairs, because remember 0 pairs are the same type of tile but different shades. But I can remove matching sets. I can remove equal amounts from both sides. I have that and that on each side. So I can take away my x squared tile and then take away my x squared tile as well, whatever that value is. Here's how we show it. Circle with an arrow. Notice it's a different annotation than the zero pairs. Okay, this shows that we are removing equal amounts from both sides. Okay, so what that leaves us with, here's my my legal move would be I subtracted x squared from both sides. Okay, so we're taking away x squared, and as we take away x squared, we now have what's left. That's -5, and this is -4. Right, so -5 and -4, we can see now which one is greater. Right, we know that mat B is greater than mat A by 1. Now, let's say you're not quite sure, but you can see I still have matching tiles on both sides. I can still do this legal move. I can remove some equal amounts to make this a little bit easier. Let's see. So my next move would be I can take away 4 negatives from this side, and I could take away 4 negatives from this side, and I'm taking away the same thing. Now what that leaves me with is -1 on the left, mat A, and 0 on mat B. So what has happened was, when I removed -4, notice that the relationship was the same. Mat B was bigger than mat A by 1, and mat B is still bigger than mat A by 1. So you can see that removing the identical parts did not affect the relationship. -5 is smaller than -4 by 1. -1 is smaller than 0 by 1. So this is the relationship that we are maintaining. That means from the very beginning, x squared plus x plus -x plus -5 is smaller than x squared plus x plus -x plus -4 by 1. We just didn't see it as clearly until we simplified. So this is the whole purpose of that simplification process. All right, and then let's do the next one. Same process. All right, so we're starting with our original expression. Okay, our original expression is x plus 7 plus -1, and then mat B, we have x plus 4 plus -2. All right, and then just go through our steps. First, we're going to take out our zeros, and then see what we have left over. Okay, so our zeros are going to be, we have 1 and -1, and we have 2 and -2. Okay, we don't have to put our zeros in one circle as long as we show the same thing. Circle with a slash through it means zero pair. Okay, so this leaves us with, on the mat A, we now have x plus 6, and on the right we have x plus 2. Okay, the x's might throw us off a little bit, so I'm not sure which one's greater than the other. So let's do our removed matching parts. So that gives us a 2 we take away from the mat A, and 2 we take away from mat B. So let's see what this does. So I'm going to take away 2, and that leaves me with x plus 4, and that leaves me with x. Okay, so I took away another set of matching sets. I can take away the x, and I can take away the x. Okay, notice the action symbol is different from the zero pair. Okay, so what that leaves me with is, when I take away x, I now have 4 on the left side, and I have 0 on the right. Okay, and as we can tell, if we go one step forward, we can still see whatever number that x is, a is going to be 4 bigger than that. And then we did a legal move, and that's still true. Mat A is bigger than mat B. So mat A is greater by 4. Okay, again, which was still true on the previous move.